Welcome back, Math 10s. Tronis here. We're going to dive into 2.5 now. And this is where we start to change things up a little bit. We're going to go back to these polynomials like we did when we started this unit. But remember, we started by expanding and multiplying them out. Then we learned how to prime factorize, which we were just dealing with numbers, no variables, no polynomials there. And now we're going to come back to it and try to reverse that process. So let's bring it back. Factoring is just like breaking a polynomial into its pieces. We call those pieces factors. And factors are things we multiply together if we want to go back to our polynomial again. So we've already learned how to expand. That was 2.1. We did a ton of practice on that. Okay. Um, and now we're going to take factoring to another level with polynomials. They are the inverse, which is just a fancy word for reverse. Okay. Processes. So in arithmetic, let's take something really simple. We could multiply factors to get a product. Let's take something simple like 2 times 6. And of course, that would give us a product of 12. Product, remember, is multiplication of factors. And we could reverse that. In arithmetic here, we're just dealing with numbers. If I started with 12, I could break it into some factors. Now, we're not doing a prime factorization here. We're just going to go right back to what I had above. I could break it into two factors like 2 times 6. And in algebra, we can do the exact same thing. So let's take a basic, let's do something like 2 times 4 minus 3x. Okay, and we learned how to expand this. You actually learned how to do one this simple in grade 9, but we would multiply the 2 in, feed the chickens, distribute whatever works best for you, and we would get a brand new polynomial here. 2 times 4 is 8, and 2 times negative 3x is negative 6x. Okay, and now we're going to learn, how can I reverse this process? How can I go basically from red to green? So if I had 8 minus 6x as my polynomial, how could I factor it to get back to these two factors, the 2 multiplying the other factor, which was 4 minus 3x? How could we do that? And that's might be really clear with this easy example, but we're going to look at a few examples here and see if we can find a quick pattern to make our life a little easier. And this stuff does not take that long at all, and it'll be like riding a bike. All right, assuming you can ride a bike. Shouldn't make that assumption. So we can determine the GCF of a set of monomials. Remember, monomials are just basically each one of them is considered a term. Okay, so these are terms. The same way we did a GCF when we had a set of numbers. Okay, we had a set of numbers and we were finding GCFs using prime factor trees. Let's do something similar. So first term here, we got 2x squared. I'm going to break that into its basic core factors. So 2 is already prime, and then x squared we can represent as x times x. Okay, let's look at 8x. Now, if you forget how to break 8 into primes, just a reminder, we could do a quick prime factor tree of 8 is equal to 2 times 4, and 4 is equal to 2 times 2, and there's my 3 primes. So let's write it as 2 times 2 times 2 times x. Okay, and we're going to do exactly what we did before. How do I find my GCF? Well, before we did it with just numbers, and in this case, it would have been, oh, we have one common 2, so the GCF is 2. But now we also have variables. So we're going to find how many common variables we have, which is 1x in common. So our GCF is going to be 2 times x. Let's look at something bigger. All right, so if we have 16 c to the 3d, let's break that into its prime factors. Again, you can do a tree if you need to, but that's going to be the same as 2 times 2 times 2 times 2. And then we have 3 c's, c times c times c, and 1d. And let's look at 8c squared now. Let's break that apart. Well, we know 8 is 2 times 2 times 2, and we have 2 c's this time. All right, let's do the exact same thing. Let's find our common primes, which in this case we have 3. Whoops, let's change colors there. Let's go back to green. We got 2 2's here, 2 2's here, pair of 2's here. That's it for the 2's, but then I have 2 common c's and no d's. So my GCF this time is going to be the three twos, 2 times 2 times 2, and the two c's. But we know we can write that in a shorter form. 2 times 2 times 2 is 8, and c times c is c squared. Let's do one more, and then we'll talk about the pattern we might be noticing now. 36 and 42 first. So let's deal with 36 a b cubed c squared. Let's break that apart. Well, 36 prime factorization, if I remember, is 2 times 2 times 3 times 3. And we have 1a this time. We have 3 b's and 2 c's. Okay. And then for 42 ab squared, 42 is breaking up into 2 times 3, which is 6, and then times 7 is going to get me the 42. And we have 1a this time and 2 b's. All right, let's find our common factors. We have a common 2, we have a common 3, and looks like that's it for the primes. And then for variables, we have one common a and 2 common b's. So our GCF in this case, again, is going to be 2 times 3 are the common primes, and then we have 1a and 2 b's that are in common, giving us a final GCF of 2 times 3 is 6 times a times b squared. Okay, what are we noticing about the pattern here? Well, GCF for multiple terms or multiple monomials, we basically have to find what's the GCF of the numbers, okay, which we can use prime factor trees if needed. And then what is the lowest exponent on each variable that's in common? So you can think of it this way. There's an x to the 2 and an x to the 1 in A. Well, our lowest power on the x, our lowest x power is 1. Hence, we have an x to the 1 in the GCF. That's the most x's in common. And over here, the same thing applied with the C's and the D's. We have 3 C's here and 2 C's here. Well, the most in common or the lowest power is a 2. So I ended up with 2 C's. There are no D's in the second term. So there are no D's in common. You could think of it as a D to the 0, essentially. So we have no D's in common with our GCF. Same thing applied here. We got our GCF of 36 and 42, which a prime factorization might help you to discover that it's 6. And then we had one common a and two b's. Well, if we look at that, a to the 1 and a to the 1, that is our lowest common power of the a's, and our lowest common power of the b's is b to the 3, b to the 2. So 2 is our lowest, so 2 is our GCF. So let's write that in a couple sentences and try some polynomials out. So we can see the GCF works out to be the largest, we already know this about numbers, the largest number that divides all the coefficients, right? Coefficients is the number in front, along with the lowest power, that's what we saw above, of each common variable, or on the other page, I should say. So we're going to do this with 3 easy steps. When we have a polynomial now, not just a couple monomials separated, we have to pull out our GCF first. Okay, we're going to put that in front. Then we're going to light our leftovers. I'll show how we do that in brackets. In step 3, I'm not going to do other than the first one here, but this is always great in all of these sections, 2.5 all the way to the end of this unit. You can verify, you can self-check every single thing you do to make sure you know you got the correct answer, which I highly recommend, self-checking your stuff. Okay, so let's take a look at this. We have two terms. We have an 8d and then we have adding 20d squared. I look at both terms and say, what's the biggest number I can factor out of my coefficients? Well, of 8 and 20, that's going to be 4. And then what's the lowest variable? Okay, lowest power on the d's. So we have d to the 1, d to the 2. So the most d's I can pull out as a GCF is 1d. And now let's figure out our leftovers. Well, our leftovers, one way of thinking of it is whatever's left over will be the same amount of terms that I started with. So I have 2 terms. I'm going to have 2 terms in my leftovers every single time. And so this 8d, one way to think of it is 4d times what gives me 8d? Well, that would be 2. And then 4d times what would give me 20d squared? Well, that would be positive or plus 5d. And this is the one time I'm going to do it in this lesson to save time, but you can always then verify to see, did I do this correctly? And of course, if I go 4d times 2, I'm going to get 8d, and 4d times 5d is going to give me 20d squared, which I am back to the original polynomial up here, okay? That's not the best arrow. There we go. So that is our verify step. Okay, always a great way to check if you did things correctly. Okay, let's look at B. I again have three terms, so I want to look at my numbers first. What's my greatest common factor of 6, 12, and 18? Well, if I look across that, it's actually 6. So I'm going to divide out the 6. And then if I look at my variables, well, there's no z's in my first term. This is a constant, so I can't pull out any variables at all. So I'm going to figure out now, what are my leftovers? I got my GCF. Now remember what I said, my leftovers must have the same amount of terms as I began with. So what 6 times what gives me 6? Well, the most basic way to figure that out is 6 divided by 6, which is 1. Okay, and now 6 times what gives me negative 12z? That's going to be negative 2z. And 6 times what gives me 18z squared? Well, that's going to be positive 3z squared. Okay, so just a side note too is I'm saying 6 times what? 6 times what I keep saying. The other way, if you're strong with division or your division tables, is just say 6 divided by 6, 12 divided by 6, 18 divided by 6 gets us the same results. Just be careful of your signs. All right, let's try C. Okay, what is my GCF of my coefficients? Negative 20, negative 30, negative 25. I know that that's going to be 5. There's nothing bigger that's going to divide all three of those because they end in zeros and fives. And there's something that we need to take note of here. I'm actually going to take out a 5, but I'm going to take out a negative 5. So I want you to add a little note here, and this is important, especially later on, is that if the leading term is negative, okay? So I'm going to say if first term is negative, GCF must be negative, meaning divide out the negative, factor out a negative of all the terms. Okay, so don't forget to do that. We're going to use it a whole bunch in the next lesson. All right, so we just got to be careful with our signs now, but we haven't done our variables yet. So of the C's, I have C to the 4, C to the 3, C to the 1. Most C's I can take out is 1. C, D to the 1, D to the 2, D to the 1. The most D's I can divide out is 1. So now let's write our three terms, right? I started with three terms. I'm going to have three terms in my leftovers. So negative 5 times what gives me negative 20? So careful with your signs. That's going to be positive 4. And now I've taken out one C, so I have C to the 3 left over, and I've removed the D, so there's no D's in the first term. Next, negative 5 times what is negative 30? Well, that's positive 6. I've removed one C, so I have two C's left over. One D's been removed, so I have one D left over. And we're on to the next term. Negative 25. Here's the way other way. Negative 25 divided by negative 5 gives you positive 5. Okay, and I've divided out, factored out the C, factored out the D. There are no variables left over. Let's fix this, and I don't need my bracket that far away. And we're all done. Okay, so the main difference here, I made it green just to highlight there is a must pull out a negative because the first term is negative. Okay, let's look at this one. All right, what's my GCF of my coefficients? Well, I got a 4 and nothing here. Well, there is something. There's a 1. We know that. But as soon as you have a coefficient of 1 in one of your terms, you know the GCF, okay, of your coefficients has to be 1 because the only thing that divides 1 is 1. Now, let's take a look at our variables. P, I have no P's in the second term, so I can't factor out a P. Q, I have no Q's in the second term, so I can't factor out a Q. Same thing applies with the R and the S. There's no R's and S in the other term. So in this case, and this will happen from time to time, this is essentially non-factorable. There are nothing other than a 1. There's nothing other than a 1 that I can factor out of this polynomial. So we would say non-factorable. Or I'd accept cannot factor, something along those lines. okay, because our GCF is 1. Now, this one's really close, but there's one subtle difference is this one does have an R here and it still has the R in the second term. So we changed the first term, there's an R there. Now, our GCF for our coefficients is still 1. But we do have a common variable, so I can factor out the R and figure out my leftovers. Well, everything's going to stay the same except I've taken one R out of each term. So I have 4p squared q, that R has been factored out, and then I have R squared instead of R cubed times s. Okay? And finally, let's finish off this lesson. It looks a little different, but I want to emphasize something that this is actually two terms if you think of the brackets as just being a value, because I could rewrite this as something like 3x times y minus 2 times y. Okay, that's the exact same thing if I say, well, y could equal x plus 4. So don't let that throw you off. These are two terms. It is 3x times a thing. It is negative 2 times a thing. So these are terms. So what we have here is essentially two terms. So let's find the GCF of these two terms. Well, I look at the coefficients, 3 and negative 2. There's nothing common. Those are primes. I have an x here and no x's here. I'm not looking in my brackets yet, so I can't factor out an x. But the common factor in this case is actually, let's go to blue, is the x plus 4. That is our common factor, everything in those brackets. So let's factor that out. Let's keep it in the brackets because we have to keep it as a group. And our leftovers, of course, are going to go in brackets. But what are our leftovers in this case? Well, our leftovers here, if I factor out the x plus 4, my leftovers is the 3x. And if I factor out the x plus 4 here, my leftovers is the negative 2. So now we can see something similar that we worked with a long time ago in 2.1. We have two binomials being multiplied, but that is exactly how we factor it. So the only thing I want to add at the end here is that this here, okay, is our GCF. Okay, it's been factored out. And this piece, like above with all the other polynomials, is what we call the leftovers. Okay, that concludes this lesson. Pause, rewind, do what you got to do to help figure out what's going on. We'll see you in class for some practice.